Okay, so hello everybody. In our previous session, we have discussed what exactly finite language is and what exactly infinite language is. So our today's topic of discussion is objective of finite automata. Okay, in short it is called as FA. Okay, finite automata. See, in this session we will just discuss objective of finite automata. Okay, in our next session actually we will discuss exact definition of finite automata. Okay, so to understand what exactly objective of finite automata is, we have to take reference of previous point. Okay, so in our last lecture we have discussed what exactly finite language is, and also in our last session we have discussed what exactly infinite language is. Okay, so I hope you all are still remember that particular point. Okay, if you have not yet gone through our previous session, then I request you all to please do watch our previous session first. Okay, and then proceed with this one. Okay, so let us revise these points in short. Okay, so that it will be easy for us to understand our further concept. Okay, so here see, in our last session we have taken an example of alphabet sigma. Okay, that sigma contain two symbols in it. Okay, a comma b. This example we have already discussed in our last session. So here see, I am just taking same example. Okay, we'll just discuss one example of finite and one example of infinite language. Okay, so here see, suppose your question is like define language of length 2 on what? On sigma, where our sigma is what? This is our sigma. Okay, sigma contains a comma b. Okay, so same question we have already discussed. Okay, so let us revise it. So how to define this language? Let us use letter L1 for denoting this particular language. Okay, so what is meaning of this particular question is, while mentioning element in this language we have to take care of this condition. Okay, we have to list out only such element in this set whose length will be 2. Okay, so how many possible combinations will be there? So here see, I am just going to mention all possible combinations. So first combination is AA, length is 2. Okay, then AB, then next one is BA, and finally BB. Right, so this is what? This is a finite language. Why this is finite language? Because as far as this language is concerning, in this language we have to mention a string of length 2 only. Okay, and only 4 possible combinations are there of length 2. Okay, so that 4 number is fixed, and because of that reason this language is called as finite language. Okay, so similarly let us discuss one example of infinite language as well. Okay, so suppose if question is like define language that starts with a. Okay, on what? On sigma, where our sigma is same, common. Okay, for both questions. Okay, that is A and B. Now let us use letter L2 for denoting this language. Okay, now this time which condition is given? We have to mention such a string in this language where those string must starts with what? Must starts with A. Okay, so how many such strings we can mention? So first string will be A itself, starts with A. Okay, then after that, after A you can write any combination. Like after A you can write B. Okay, you can write ABB. Okay, you can write AB. Okay, only required condition is what? It must start with A. Okay, if you want to add one more element, you can add ABB, A, B. Okay. So such how many strings we can form which will satisfy this particular condition? There is no limit. Here we can form such infinite number of strings. Okay. And because of that reason, this L2 language is called as what? Is called as infinite language. Okay. Now I hope this concept is clear for you. Okay. Now let us come back on this particular point. Okay. Now actually we have to discuss objective of finite automata. Okay. Objective means what? We have to just discuss where finite automata can be used. Okay. For what purpose finite automata can be used. Okay. Okay, now so let us assume that we are having these two languages. Okay, first language L1 which is finite and second is L2 which is infinite. Okay, now let us create one scenario. Okay, suppose if someone give you some string, let us call it as an input string. Input string. Okay, suppose someone give you some input string, let us say BB. Okay. Here I just want to create one question. Okay, what we are having in the input? In the input initially we are having L1 language and then we are having L2 language. Okay, so let us first proceed with L1. Okay, so in the input we are having L1 language which is finite. Okay, and then user has given one string that is BB, and what is question here? We have to check whether this input string is present in L1 language or not. I repeat, here what is question? We have to check whether this input string BB is present in this L1 language or not. Okay, now you may think like this question is very simple, right? Here you directly by observation we may say like yes, BB is present. Okay, but it's not like that. Okay, this is not as simple as that one. Okay, now here twist is what? Here we don't want to solve this particular question manually. We don't have to solve this particular question manually. Here we have to solve this particular question on machine. On machine, that is on computer. Okay. Now suppose we are having computer. Suppose this is a computer. Okay. Our question remains same. Okay, that is what we have to check whether this input string is there in this language or not, but not manually. We have to solve this with the help of machine, with the help of computer. Okay, now what are the different steps that we have to follow if we want to solve this particular question on machine, on computer? Okay, see, now think like a programmer. Okay, what will be logic here? If we want to check whether this string is present in L1 or not, then what will be logic? We have to first compare this BB with this first element. If match found, then present, otherwise absent. Here match not found, not found, not found, match found means present. Okay, but see, for that what are the steps that we have to follow? We have to first see this language, we have to first store on machine, on computer. Okay, because as I said earlier, we have to perform this particular task with the help of machine. Okay, so what will be input that this particular computer will require? Initially computer will require what? L1. Okay, all elements of L1. Okay, and then we may take one input string from user. Here we will write one program. Okay, where in the program, in the computer memory, we have to initially store all L1. Okay, and then we have to accept one string from user. Okay, and then that string we have to compare. Okay, now see, this type of program you have already written somewhere in SPA or maybe in data structure. Okay, this program is just like searching element from an array. I hope you all still remember that particular program. Okay, searching element from an array. So if we want to write that type of program, then we have to first store all those elements in this machine in an array, and then we have to write logic to compare this input string initially with first, then second, then third up to last. Okay, so same you can directly just compare this first case only with which program? As I said earlier, with the program where we have to search element from an array. Okay, Now see, as far as this first case is concerning, it will be okay. There will not be any problem. Okay. Now here I just want to discuss one more point. Okay. What I said, this is a machine. This is a machine. This is a computer. Okay. And we all know that computer is having some memory associated with it. Okay. For example, like suppose this machine is having 1 TB memory, hard disk. Okay. You are quite familiar with this. Okay. Or suppose some machine you may find with 2 TB hard disk. Okay. Now see, any machine, not only computer, any machine always have finite amount of memory associated with it. Finite amount of memory. Okay. Some machine you may find with 500 GB hard disk, some maybe 1 TB hard disk, some maybe 2 TB hard disk. But it will never happen like some computers are having infinite amount of memory associated with it. This will never happen. Now, as far as this first language is concerning, how many elements are there? 4 elements. Only 4 elements, because this is finite. So if only 4 elements are there, those elements we can easily store in this space. Okay. But when we consider second situation, here what I said, this is what type of language? This is infinite language. Infinite language. Infinite means there is no restriction on number of strings which are present in that particular set. Okay, in that particular language. So if your data is infinite, if your language is infinite, then it is not possible for us to store this infinite language in a finite memory of computer. This point is slightly complicated for understanding. Okay, I just want to revise. There will not be any problem related with first language, because this is a finite data, finite language. So finite storage we can store, finite data we can store in finite amount of memory of computer. Okay, but when your language is infinite, if you are having infinite amount of data, then how it is possible for us to store that infinite data in a finite memory of computer? It is not possible. So this is a problem. First of all, you try to understand problem here. Okay, later on we'll just discuss solution for that. Okay, so this is actually a problem, and to overcome this particular problem, they have developed a concept of finite automata. FA, finite automata. Okay, now I just want to discuss, rather draw one short diagram which will explain use of finite automata. That is actually our main point of discussion, objective of finite automata. Now what is objective of finite automata? See, suppose you are having one language, this language is infinite language. Let us assume that this language is infinite language. Now I hope what exactly infinite language is, this point is clear for you. Okay, still if you are finding difficulty in understanding infinite language concept, then you please do watch our previous session. Okay, and then proceed with this one. Okay, now what I am saying, suppose we are having one language L which is infinite. Okay, and then suppose we are having one input string. Okay, just previous concept I am just trying to discuss it with the help of small diagram. Okay, what we are having infinite language L and then one input string. Okay, now where finite automata comes in picture? Suppose here there is a finite automata. Okay, finite automata. So what is use of finite automata? Rather, what will be input that we will give for finite automata? We will give first input as language. Okay, language means that set. Okay, and then we will give one input string. And then what is job of finite automata? This finite automata will check whether this input string is present in this language or not. What I said, this finite automata will check whether this input string is present in given language or not. Okay, and if it is present, then what will be output that will be given by using finite automata? Finite automata will give output in this form, either yes or no, or no. Okay, now see, in the name itself, which term they have used? Finite automata. Means whatever finite automata that we will consider, it will be finite only, not infinite. So that finite automata we can easily store in a finite memory of computer. Okay, our previous problem, as I said earlier, if your language is infinite, it will not be possible for us to store it in memory of computer. So how we overcome that particular problem? By introducing finite automata. Okay, so instead of storing complete language in memory, we will just store what? Finite automata. Now what exactly finite automata is, what is its definition, that particular part we will discuss in detail in our further subsequent lectures. Okay, but for now you just remember this point. What is objective of finite automata? Rather, what will be input that will give to finite automata? That is, first one is language, then input string, and then what is job of finite automata? It will just check whether this input string is present in this language or not, and what will be output that will be given by finite automata? This will be in terms of yes or no. If this input string present in L, then it will just give output as yes. Otherwise, if it is absent from given language, then this will give output as no. Okay, so this is all about objective of finite automata. Okay, see, as I said earlier, see, these concepts are very difficult for understanding. Okay, this particular subject, TCS, is considered as one of the complicated subject of computer engineering department. You can verify this with the help of your seniors. Okay, and as I said earlier, in a 80 marks paper, for around 60 to 65 marks, there will be problems. Okay, this is not a theoretical subject. Again, there is a twist in the name itself. What is the full form? Theory of computer science. Okay, even though full form is theory of computer science, in the paper there will be problems for around 60 to 65 marks. Theory will be only for 10 to 15 marks. Okay, so from next lecture onwards, we'll just start with the definition of finite automata. Okay, so if you find any difficulty in understanding any point, then you can ask me your queries, okay, through comments. Otherwise, you can ask your query through our official WhatsApp group as well. Okay, so that's all for this session. Stay tuned for further updates. Thank you.